nature, a system with more energy is less stable. In other words, the lowest energy state corresponds to the most stable state of the system. So, every system tends to attain stability by losing energy. Let's see how the atoms attain the lowest energy and tend to be in a stable state. We know that the nature is associated with innumerable chemical reactions. It is a known fact that an atom is the smallest particle that takes part in a chemical reaction. Hence, most of the elements exist in a combined state in the form of molecules. The few elements which exist independently are noble gases. This is attributed to the stable electronic configuration and the minimum energy they possess. Hence, the atoms of other elements which do not have stable electronic configuration and the minimum energy combine with other atoms of elements to form molecules. Thus, these atoms attain stability by the means of bond formation. The process of bond formation is associated with the lowering of energy of the system. The attractive force which holds various atoms together in a molecule is called a chemical bond. Cosell and Lewis made an attempt to explain the chemical bond formation in terms of electrons. According to them, noble gases are chemically inert because they have stable electronic configuration. The stable electronic configuration is due to the presence of either 8 electrons in the outermost shell, called octet configuration, or 2 electrons in the first shell, called duplate configuration. Hence, they exist independently in atomic state. On the contrary, the remaining elements having less than 8 electrons in the outermost shell are chemically reactive. Hence, they combine with other atoms of elements by means of chemical bonds so as to attain stable octet. So, they do not exist independently but exist in combined states as molecules. Thus, the Cosell-Lewis approach provides an explanation for the requisite of formation of bonds. Later in 1916, Cosell and Lewis developed the electronic theory of valence or theory of chemical bonding to explain the chemical bond formation between the two atoms. According to electronic theory of valence, every atom tries to attain octet in its valence shell by losing or gaining or by sharing of electrons. This is known as the octet rule. Only valence electrons are responsible for the formation of chemical bond. Except valence electrons, the remaining part of the atom, that is the nucleus, with the inner shell electrons, is called kernel. Lewis proposed simple notations to represent valence electrons in an atom. These notations are called Lewis symbols. As per Lewis symbols, the number of valence electrons of an element are represented as dots around the symbol. Let's look at the Lewis symbols of the elements lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon as shown. The number of dots around the symbol gives the number of valence electrons. These valence electrons are useful to calculate the group valence of the element. The group valence of an element is equal to number of valence electrons of an element, or 8 minus the number of valence electrons. This is the significance of Lewis symbols. Now, let us look at the formation of ionic bond or electrovalent bond, which was explained by Cosell by considering the following facts. Halogens which are highly electronegative and alkali metals which are highly electropositive are separated by noble gases in the periodic table. Hence, halogens gain an electron, whereas alkali metals lose an electron to form negative and positive ions respectively. The positive ion and the negative ion thus formed attain octet configuration. The two oppositely charged ions approach each other and form an ionic bond or electrovalent bond. The electrostatic forces of attraction that holds the two oppositely charged ions together is known as the electrovalent bond. On the basis of these facts, let's explain the formation of sodium chloride. The electronic configuration of sodium is 2, 8, 1, whereas the electronic configuration of chlorine is 2, 8 and 7. When both sodium and chlorine combine together, sodium loses its one valence electron and forms positive ion, that is, sodium ion, whereas chlorine gains the one electron lost by sodium and forms the negative ion, that is, chloride ion. The sodium ion and the chloride ion attain the octet configuration of neon and argon respectively. These two oppositely charged ions approach each other and form sodium chloride. Due to the strong electrostatic forces of attraction between these oppositely charged ions, an ionic bond is said to be formed. Thus, sodium chloride is formed by the transfer of electrons from sodium to chlorine. The number of unit charges present on the ion is called electrovalence. In sodium chloride, sodium is assigned a positive electrovalence of 1, while chlorine is assigned a negative electrovalence of 1. Similarly, we can explain the formation of potassium chloride, calcium chloride, magnesium oxide, and other ionic compounds. On the basis of Cosell and Lewis' approach towards chemical bond, we can explain the factors that affect the formation of ionic bond. The formation of ionic bonds depends upon the following three key factors. First, the ease of formation of a cation. Second, the ease of formation of an anion. And finally, the arrangements of the positive and the negative ions in the ionic solid. Let us understand this by considering the formation of sodium chloride. In the formation of sodium chloride, sodium loses one electron and attains the configuration of its nearest noble gas, neon. The amount of energy required for the ionization of a neutral atom, which is sodium atom in this example, is called ionization enthalpy. It is always endothermic. Similarly, chlorine accepts one electron to attain the configuration of its nearest noble gas, argon. The amount of energy liberated for the gain of electrons by chlorine atom is said to be electron gain enthalpy. It is represented as delta EGH. It is defined as the enthalpy change when a gaseous atom gains an electron. Note that the electron gain enthalpy may be exothermic or endothermic. Thus, sodium forms a positive ion, that is a cation, whereas chlorine forms a negative ion, that is an anion. Due to the strong electrostatic forces of attraction between these oppositely charged ions, they are held together to form sodium chloride. Now let us understand how ionization enthalpy and electron gain enthalpy affect the formation of an ionic bond. The ease of formation of a cation depends on the magnitude of the ionization enthalpy. Lower the ionization enthalpy, easier the removal of electron, and hence greater is the ease of formation of cation. Similarly, the ease of formation of an anion depends on the magnitude of the electron gain enthalpy. More negative is the electron gain enthalpy, greater is the ease of formation of the anion. Hence, we can conclude that lower the ionization enthalpy and higher the negative value of electron gain enthalpy, greater is the ease of formation of an ionic bond.